Imagine waking up tomorrow morning, opening your curtains, and discovering that the sun is gone. In its place is a red star so enormous that Mercury, Venus, Earth, Mars, and much of the asteroid belt are now buried deep inside it. There is no sunrise. There is no Earth. There is only fire. This star is called UY Scuti, and for years it was described as the largest star humanity had ever discovered. But how big is it really? How many suns could fit inside it? How long would a commercial airplane need to fly around it? And what would happen if we placed this cosmic monster at the center of our solar system? To understand UY Scuti, we first need to understand just how ridiculously large our own sun already is. The sun is so big that about 1.3 million Earths could fit inside it by volume. If Earth were the size of a small marble, the sun would be roughly the size of a large exercise ball. And yet, beside UY Scuti, our sun would look almost insignificant. Current estimates place UY Scuti's radius at roughly 909 times the radius of the sun. That means it is approximately 1.26 billion kilometers from one side to the other. To put that into perspective, the average distance between Earth and the Sun is about 150 million kilometers. So UY Scuti's diameter is more than 8 times the distance between Earth and the Sun. Imagine placing Earth on one edge of the star and trying to look across to the other side. You would not see another continent. You would not see another planet. You would be looking across a distance larger than several Earth-to-Sun journeys placed end to end. And remember, we are talking about one star. But here is where the scale becomes almost impossible to comprehend. If you could somehow empty UY Scuti and fill it with copies of our Sun, approximately 750 million suns could fit inside it by volume. Not 750, not 750,000, around 750 million. Imagine every person in Europe owning their own sun. You could place all those suns inside UY Scuti and still be describing only one star. Now imagine trying to fly around it. A commercial jet normally travels at around 900 kilometers per hour. If that aircraft could somehow survive the heat, remain fueled, and fly around the star without stopping, the journey would take roughly 500 years. You could board the plane during the time of Christopher Columbus, and it might only be finishing the trip today. And that is without delays, connections, turbulence, or someone leaning their seat all the way back for 5 centuries. Light would obviously make the journey much faster. Light travels nearly 300,000 kilometers every second. At that speed, it can travel around Earth more than 7 times in 1 second. But even light would need about 70 minutes to cross UY Scuti from one side to the other. A beam of light could leave Earth, reach the Moon in just over 1 second, and yet it would spend more than an hour crossing this single star. UY Scuti is located roughly 5,900 light-years from Earth in the constellation Scutum. That means the light we see from it today began traveling toward us thousands of years before modern telescopes existed. If you tried reaching it in a commercial airplane traveling non-stop, the trip would take more than 7 billion years. That is roughly half the age of the universe. So unless your airline offers immortality, unlimited fuel, and free checked luggage for 7 billion years, you are not arriving. Now let us perform the experiment that makes this star truly terrifying. Let us remove our Sun and place UY Scuti at the center of the solar system. Mercury disappears immediately. Venus disappears. Earth disappears. Mars disappears. Much of the asteroid belt would also be buried inside the star. UY Scuti's outer surface would extend more than 4 times farther from the center than Earth's current orbit. Jupiter, however, would likely remain outside the visible surface based on the newer size estimate. But that does not mean Jupiter would be safe. Replacing the Sun with UY Scuti would completely transform the solar system. The intense radiation and stellar winds would devastate anything nearby. Temperatures would become unimaginable. Planetary atmospheres could be stripped away. Orbits could change because UY Scuti is far more massive than the Sun. The solar system we know would no longer exist. Earth would not be slowly roasted. It would already be inside the star. There would be no dramatic moment when people looked up and saw a larger sun approaching. Our planet would be surrounded by superheated plasma. The oceans, atmosphere, cities, mountains, and every living thing would be destroyed. Basically, Earth would go from being a planet to becoming a very small ingredient in an extremely large cosmic soup. But UY Scuti is not simply a giant version of the Sun. It is a red supergiant, a star near the final stages of its life. Our Sun is currently stable, steadily converting hydrogen into helium in its core. UY Scuti has already expanded enormously as its internal fuel and structure have changed. Its outer layers are extremely extended and much less dense than the Sun. So although UY Scuti is hundreds of times wider than the Sun, it is not hundreds of millions of times more massive. This is similar to comparing a giant inflatable balloon with a bowling ball. The balloon can be much larger, but that does not automatically make it heavier. UY Scuti may contain only a few dozen times the Sun's mass, even though hundreds of millions of suns could fit inside its volume. That is also why measuring stars like UY Scuti is so difficult. It does not have a clean, solid surface. Its outer atmosphere is enormous, turbulent, and constantly changing. The star also pulsates, becoming brighter and dimmer over time. Measuring its edge is like trying to measure the exact size of a cloud from thousands of kilometers away. Where does the cloud truly end? Does the faint outer mist count? What if the distance estimate changes? Even a relatively small error in distance can create a huge difference in the calculated size. That is exactly what happened with UY Scuti. An older estimate suggested a radius of about 1,700 suns, which would have placed its surface near or beyond Jupiter's orbit. Newer distance measurements reduced that estimate to around 909 solar radii. That is still unbelievably enormous, but it demonstrates why scientists are careful when declaring any star the absolute largest. UY Scuti may not currently hold the unquestioned title of biggest known star. Other stars may be larger, and some candidates have enormous uncertainty around their measurements. The honest answer is that ranking the largest stars is difficult because these stars are distant, unstable, and surrounded by extended atmospheres. But UY Scuti remains one of the greatest examples of how extreme a star can become. And its story does not end peacefully. One day, UY Scuti will run out of the fuel needed to support its core. Gravity will take over. The core will collapse, and the star is expected to end in a tremendous supernova or a related core collapse event. For a brief period, that explosion could shine with the power of an entire galaxy. The blast would throw newly created elements into space. Carbon, oxygen, iron, and other materials could eventually become part of new stars, new planets, and perhaps even new forms of life. That means the death of one giant star can help create the ingredients for future worlds. The atoms in your body were produced by earlier generations of stars. The iron in your blood, the calcium in your bones, and the oxygen you breathe all have cosmic histories. Stars are not simply lights in the night sky. They are factories that build the universe. UY Scuti is thousands of light years away, so it poses no danger to Earth. But it gives us a glimpse of just how enormous and violent the universe can become. Our Sun feels gigantic because it dominates our sky and controls our entire solar system. Yet somewhere in the Milky Way is a star so large that our Sun would look like a tiny glowing dot beside it. A commercial jet would need 5 centuries to circle it. Light would need more than an hour to cross it. Hundreds of millions of suns could fit inside its volume. And if it replaced our sun, Earth would not orbit it. Earth would already be inside it. The universe does not struggle to make us feel small. It only needs to show us what is already out there.